Welcome to the embedded session of the Western Digital Flash Perspective. My name is Hubert Verhoeven. I'm in charge of Western Digital's automotive, mobile and emerging business. Before we go into storage, I would like to get us all a little bit grounded on connectivity and connected devices in general. If you think about it, and the graph here sort of reflects that, right? The number of connected devices in the world is shooting up dramatically. So in 2030, the expectation is that there will be about 80 billion connected devices online. In 2025, that will translate to about 350 devices being deployed per second. Now let's think about it for a second, right? That means with 80 billion devices in 2030, that over 10 devices are deployed per person on Earth. So we're now moving from the period where you think about, do I have one smartphone, do I have two smartphones, to having 10 devices associated with what you do. So if you think about that development of devices becoming connected at a massive scale, the question becomes, what does that do to us? And then what does it do to storage? If you look at this slide, it does a whole bunch of different things, right? We can talk about the easy story of devices that are connected and generate a lot of data. Those devices, we call them endpoints at the left, and you can think about your smartphone, you can think about your security camera, but you can also certainly think about your car, which is becoming an inherently connected device. And if you think about a factory, the robots, the manufacturing infrastructure that is now also connected. These devices will generate a lot of data that will connect to edge devices and then eventually goes into the cloud, into the core, right? So one way of thinking of it is, well, that's a lot of data that goes from the left all the way to the right. Now, I want to see it a little differently. Those devices on the left, some of the devices you know, some of the devices you haven't heard of yet, will actually generate data, but they will also get data the other direction. There will be machine learning, there will be AI on those endpoints, there will be training in the cloud, and the interplay of all that data is what I'm going to be talking about today. Why do I start on the left here with a picture of a mobile phone? I just said, well, a mobile phone is a great example, and it's one that we can all certainly identify with, right? We all have a mobile phone in our pocket, and you can argue for many of us it's the second brain, and for some of my kids I would say it's starting to become the first brain. Right? So, but those mobile devices are really an incarnation of a device that is always connected, where performance is starting to matter, and where the form factor is such that the device is always connected, it's always on, and it's doing something. Now, that translates, right? That whole concept is now translating into a whole bunch of consumer pieces of electronics. Right? We can talk about a drone, which certainly as a consumer device is up and coming, but also as a commercial device. We can talk about your connected home, right? You sit at home and you say, hey, your favorite supplier, play me a piece of music, right? You have your thermostat where you can say, hey, you know, it's a little cold here. You have your car, where it used to be you got in your car and you drove, right? And you sat in traffic. Right now that car is becoming somewhat of a hybrid between an entertainment device, a device that will become more and more autonomous, and a device that doesn't just generate data, it also consumes a lot of data at high speed. And then I talked about Industry 4.0, which is the concept that your manufacturing infrastructure is inherently connected. If you think about the data that is being generated in factories and the value of that data, that is enormous, right? It is about efficiency, it is about throughput, but in general, data is becoming a new currency. What you do in your home, what you do in your car has implications certainly on how the device functions, but the data generated in the process has value to you, it has value to others. Let's take a step back maybe into that phone, right? So what is happening in phones? Smartphones, obviously a big part of our daily life, but those devices have changed, right? If I were standing here probably 5 to 10 years ago, I would talk about the form factor being smaller and smaller, right? Now, and the form factor is still important. And I would talk about talk time, right? How long could I be on my phone and talking to my business contact in China? But right now with phones, it's different, right? My kids, they don't talk on their phone anymore. They do a lot of things on their phone, but talking is not one of them, right? So right now it becomes much more of a device that is a fusion of sensors. It is a fusion of display capability, higher and higher resolution, going from 4K to 8K, cameras that are getting better and better, and in some cases actually are bordering, even with the lenses currently in phones, near professional quality. And then there's the whole concept of 5G, right? No longer do you have to wait to send your file and you have to optimize it for size. You're inherently connected at high speed. So what does that do? right? It doesn't just allow you to watch movies at 8K, which obviously generates a lot of data, right? And we will talk in storage about why that is important to the storage device a little later. But it also generates use cases that didn't used to exist. We are talking about cameras that are not just photo cameras, but they are 3D cameras. 3D not just to measure your wall and to see if your couch is going to fit in your living room, but it is also to now go into gaming, to be immersive in your environment, to use data of your environment superimposed on artificial data. So the whole concept of virtual reality, but certainly also augmented reality in the mobile handset is what is driving data and what is driving storage. Not just bits, not just more bits that need to be put into a phone, but the quality of those bits, the speed at which data is being written, the speed at which data is accessible. So the mobile platform is in itself incredibly important, and I will show in the next slides how in other markets that also that platform is being leveraged into applications that are new applications, emerging applications. So if we talk purely about the storage in phones though, just to keep us all grounded, in 2025, we expect about 457 exabytes of data to be stored in phones. And just for us to be all a bit grounded, you know, on the first slide, I talked about even larger numbers, right? There are numbers like 73 zettabyte of data is being generated. Not all data is stored. 73 zettabytes, to put it in perspective for us, you know, when we buy our storage devices, 73 zettabyte is 73 billion terabyte. It is 73 trillion gigabyte, right? So the numbers here, when you hear things like exabyte and zettabytes, these are staggering amounts of data. But now let's take a little detour from the smartphone, right? We all know the phone, we love the phone, into the devices that are becoming inherently connected devices. So let's talk about automotive. Automotive, cars have certainly been around for a long time, have been devices that had more and more electronics come into the car, initially to get engine performance to be better. Then electronics showed up to have your cabin to feel a little bit more like, you know, a little bit more like your smartphone, right? Your navigation screens, your dashboard, things started to feel a little bit more modern. But what has happened over the last 5 years or so, and is accelerating really rapidly right now, is the convergence of technologies in your vehicle. So let's talk about it for a second. So the first thing that is happening is when you're driving your car, even if that car is not autonomous yet, you have a lot of systems in your car that actually help you be safer, right? So-called ADAS, right? So the Advanced Driver Assist Systems. So these devices are in some cases relatively low-speed devices with limited storage, but in many cases, those are devices that generates gigabytes a second of data to determine your distance versus the car in front of you, to do automatic braking and speed monitoring. And then if you take that obviously the step further to autonomous vehicles, I will show you what it does to the car at that point. And then if we take that leap of faith of moving into assisting drivers to cars becoming more and more autonomous over time, the car does become your living room. What you have in your car, you expect from an infotainment perspective to be able to provide you the same type of information as you would have in your living room. Also, the car at that point is an inherently connected device. We should think about it for a second. While the car certainly has to be safe and drive correctly while the car is not connected, the assumptions of the car maker is that the car, in the majority of cases, will be connected. And that becomes important, right? I talked about data having value. That data certainly has value also for the car manufacturers. What you do in your vehicle, how that plays out, there is value in the data. Now, how the data is stored is important because that data also has value to you from a privacy perspective. It also has value from a perspective of, if you think about autonomous vehicles, the ability to trace what happens with your vehicle in case something were to go wrong. So there are use cases of actually storing that data for other purposes. So if you look at a car, probably, you know, in the future going forward, I will talk a little bit more about how that plays out. If you talk about other applications though, right, so COVID probably has accelerated this case here, VR. So VR started, certainly when we started working with major VR manufacturers and OEMs, as something that was a mobile device inspired solution. In many cases it meant that they took the technology that came out of a mobile phone and they put it with other electronics and put it close to your face with displays, and you had a decent experience, right? But if you take the latest devices, those devices are no longer mobile phone devices. They are optimized for a VR experience. Today, primarily optimized for gaming, right? So performance is important, but as you can imagine, form factor becomes more and more important too, right? If you play these games for 4 or 5 hours, battery life, how that feels when it's on your face, that all matters. So the scaling that we are doing on the mobile phone platforms, it does help tremendously and get form factors, performance, battery life, where it needs to be for VR applications. Now, VR is a story today primarily of gaming, right? And obviously, games are starting to come out that are games that are no longer just these small interactive games where it is the interesting part of being able to interact and look around you. They are becoming real gaming titles of over 100 gigabytes of content per title, right? So these specific solutions there are evolving rapidly. The titles, what you can do on VR systems will go up. But then if you take a step to the right here on this picture, right, you start talking about what AR does. So not just virtual reality, but augmented reality. So now you start talking about, is there a pair of glasses that you can wear the whole day? And let's say that you are an airplane mechanic and you're looking at a specific engine that needs to be repaired on an airplane. Can you have the overlay of what are these components? What is the diagnostics of that? What is the repair manual for certain parts, certain components? Right? So no longer are you just talking about AR in the context of a phone game where you can overlay your real environment on virtual characters, but you're talking about commercial use cases. Now, that's a different problem statement, right? Because now you have to have a device that is comfortable to wear the whole day. It has to have battery life that supports that. So it has to be smaller, it has to be lower weight, it has to be lower power. And that's where you start transitioning with your partners from a mobile leveraged platform to what do you do specifically to enable new end markets that are growing really, really quickly. And I will talk about partnerships a little later. I showed you the slide earlier, right? Data is no longer going from the left from all those devices through the edges to the core. So why is that, right? Why wouldn't you take all your data from an endpoint and move that all to the data centers? Certainly from a Western Digital perspective, we see the full gamut of customers who have embedded storage on the one hand and data center storage on the other end. So we are certainly uniquely positioned to be neutral in that discussion of how you partition your data and your data stream. But if you talk about the endpoints, what is happening is that more and more endpoints will have local processing power that they didn't used to have and local storage. Now, why is that? Local has a couple of advantages, certainly for, take a connected home example. Take the example of your smart speaker where you interact in your home with a device. A couple of things need to happen. It needs to be instantaneous, right? It needs to feel like you're having a discussion. So local processing allows you to deal with latency. You can get a quicker response to most of your questions, right? So latency, bandwidth, and bandwidth is an important question, right? If you look at take your doorbell camera, if the doorbell camera streams all data in 4K to the data center, you will use about 1/3 of your monthly data plan with a popular cable provider just on your doorbell camera, right? So locally being able to process, to extract information out of data streams with machine learning and AI becomes incredibly important so that you can transmit information and not just raw data. And then the last one is a little bit of a tricky one. It says safe. Now, what is safe, right? Safe can mean secure, but safe in this context to me means a little bit more. It means the feeling of safety, right? And that is different for all of us. It is different certainly for my kids as it is for me, as it is for my parents. Safety means that the data that is generated in your home, in your car, that you understand where the data is, where it can be used, and where it can be transmitted. We see many places in Europe, the US, and other locales where legislation is being implemented to be very specific about what data can be transmitted, what data the user has to give permission to be transmitted. So by having control in the endpoint of how the data is collected and processed, you can help give people the informed choices of what actually happens with the data. So those 80 billion devices that are going to be out there, the data there needs to be processed and stored locally. So now you have 80 billion devices, many of them having local embedded flash storage. So now, how does it all come together, right? This is not a one-party brings everything to the table discussion. If you can imagine, I talked about all kinds of different embedded devices, from your smartphone to your connected home applications, to your car, to your factory. In those cases, what is very unique, I would say, to the embedded market is that you have an ecosystem that has to come together. And if you look at that, it's an ecosystem of SoC, system on a chip providers on the bottom right, who provide the processing power that goes into those different applications. So we work extremely closely with them to make sure that our storage solutions architecturally line up. It is the operating system, right? A lot of those devices are smart devices and they run an operating system. But they don't run all Windows, they run a combination of embedded operating systems. So the partnership on the right with the chipset guys and with the guys who make the OSs has to be really, really tight to get to maximum performance. And then on the left, you have the gears here. It's more the mechanical part of what you need to do on standard bodies for storage, right? What do we do to make sure that we conform to standards, which is certainly important, but also that we contribute to standards what we believe needs to happen to make these architectures better for current products and for emerging architectures. And then the bottom one, the bottom left, is important because that is really the view of our customers, working closely on their needs today, but also working extremely closely on devices that haven't been invented yet, on what trade-offs do we make today to enable their architectures for the next 5 years. So now that you heard about how cars of tomorrow become better vehicles, let's talk about the car of today, right? So the car of today, pictorial here, a lot of devices in the cars are electronics. Some of them you touch, some of them you really shouldn't touch, and some of them your mechanic probably doesn't even know how to touch them anymore. But those devices have in common that they have individually storage on each of those endpoints, right? Whether that is in the cockpit, whether it is your navigation system, whether that's under the hood, whether that is the storage of data for self-driving cars, each of those dots is typically a point that has electronics control functionality, an ECU, and it has storage. Today's car, about 80 of those ECUs in a vehicle can be up to 850 gigabytes of storage per vehicle, right? So this is no longer just store a couple of bits that you can read out later on. This is real data per car even today. Now you can sort of see the opportunity and the challenge, right? If you look at all these connections here, this is a picture of fewer than 80 of those ECUs being connected. Now we start talking about the cars that are being developed today, right? And now you start talking about those little circles, you have a lot more of them. And what is interesting is they actually fall into what we call domains, right? You have a domain that specializes in what is happening in the cockpit, right? What is your entertainment, what do you display? You have a domain that focuses on the intelligent driving decisions that need to be made. You have a domain that focuses on the drivetrain and engine control. So what we are working on with our partners, with the car makers and their suppliers, is to define the architecture on how this all ties together, right? And you can tie this together in many different ways, but this is a way that I would say most of the vehicles being architected today are being tied together. And what it does differently is it has domain controllers. It has storage, significant storage in multiple parts in the car, and each of those domains takes care of something, a domain, right? Now, what it allows you to do is two things. It allows you to wire things differently, right? It allows you to take data that comes from one sensor, from one subsystem, and in that domain controller, where you have a stronger SoC than you would have in all those separate points, you can do your processing. You can let loose AI, ML on 10 different things that have to do with that domain, right? So all of a sudden, you have intelligence built in the car that is not just the intelligence in each endpoint, but the combined intelligence of 10 different pieces of data that you get, right? So obviously, as you can imagine, these are not decisions in automotive where somebody just says one day, let's just hook up some things and see how it works. These are multi-year discussions between us and the car manufacturers on how exactly do you lay that out? What type of storage exactly do you need to enable this? And this is no longer one type of storage, right? This is embedded storage of a slow power optimized kind in some applications. It's very fast embedded storage for other applications. And in many cases, you now see SSD solid state drives actually show up in the car, right? You see in this case, for cars being developed today, over 2 terabytes of storage in that car. That's a mix of embedded storage as well as SSDs. And this is not even talking about self-driving or autonomous vehicles. So when you start talking about the next transformation, right, the brain becomes bigger. So the next transformation will become that you have so many of those devices and endpoints in there that you have to think about where physically in your vehicle are those endpoints. So now you don't just have domain controllers, you have actually zonal gateways. So your car may have 4 areas depending on location of the car that brings together all those signals. And that may be combined with domain controllers. So now you talk about hundreds of endpoints. You talk about 4 terabytes per vehicle easily. Some of our customers do up to 10 terabytes in self-driving applications. And then you talk about the data you generate, right? Now you're talking about generating a gigabyte per second, right? You're driving around and a gigabyte a second is being stored somewhere in your vehicle. We are super excited certainly to be a part of the ecosystem where we work with car OEMs, not just to make sure that they have what they need from a quality perspective and from being a good supplier perspective, but to also make sure that we are here for the next generation, the domain controller transition, as well as the generation right after that, which is the zonal picture. We, with our embedded products, are certainly not always as visible as we are with our storage products like an hard drive or a solid-state drive. But our embedded memory powers most of the devices that you touch today, whether that is your smartphone, whether that's your car, whether that is your Android TV box, or in many cases, whether that's a robot that actually puts all these things together that you use. So the embedded story is one of explosive growth, right, to 80 billion devices, to increase storage, whether that storage increases in your smartphone because you take higher resolution pictures, you take more videos, or whether that data, as I just made plausible, is increasing because of the electronics that goes into your car. We are the center of bringing that all together with our partners. So then, if you take that one step further, obviously the question is, okay, so things are changing, are you changing too? And we are changing. So today we'll be talking about a specific product for the embedded markets, which is the EU551. By itself, not the most sexy name, but certainly it is a device that has a lot of functionality that actually ticks the boxes if you look at the picture to the right. We talked on the bottom right, so we enable full-speed storage in these devices, whether the device is connected at 5G, Wi-Fi 6, right? We enable that device to take all the data, move all the data, and we are there to store that and to have that completely accessible. I will give you a bit of an example in that second shell. Let's take the smartphone. What we do in this device is we get about a 90% increase in sequential write. Now, it gets a little technical, but what does it mean to you when you have your phone? Right? When you download something, that data comes in, and you store that sequentially. So a 90% increase versus the previous generations of sequential write. Now, if you look at, on the other side, take sequential read, right? You have to start your app. Now you need to read data, right? So we get 30% increase on sequential read. Now, you're going to say, well, I don't just download and I open my app. You know, I have 5 apps running at the same time, right? How does that all work? So we get about a 100% increase in random read and about 40% increase in random write. So now when you have 5 applications running on your device, it actually gets you, from a read perspective, a doubling in speed versus previous generations. So all of a sudden you're talking about this device in the mobile context, where certainly the first deployments are, not just being that excellent mobile device to get your phone to turn on quicker, to respond quicker to switching apps, but to also be able to store your video, your photos, your burst mode, your TikTok, whatever else you would like to store, right? But it also acts as a platform for us. That same platform is now getting expanded to be also the base platform for storage in AR, in VR, and in automotive. So for us with our partners, mobile is a great place to start with the volumes in mobile and the use cases. But more and more with partners, we work very early on to make sure that we take that same base technology and give them solutions for markets that go well beyond that. So this brings us to the close of my presentation about embedded memory at Western Digital. I hope I shared some of my excitement with you on embedded memory in general. Just to bring it back to the beginning, right? I talked about 80 billion connected devices being deployed. The number of devices no longer being limited by the number of people in the world. Over 10 times the number of devices per person. Those devices not just being connected, but those devices actually needing storage at a device. And that storage at a device will get bigger and bigger and will enable you to do local processing, AI, machine learning at a device, so that you get better performance certainly, so that you feel safer because you can control what happens with that data, right? So 80 billion devices enabled by embedded memory. I also talked about certainly the mobile phone, the smartphone still being the center of most people's universe. I didn't talk yet about the fact that in 2019, about half the world had access to a cellular connection. In 2025, the expectation is that 75% of the world will have a smartphone connection, and for most of those people, that will be their main internet connection. So for us, certainly to work with our partners and taking that smartphone platform as a starting point for all those devices that already are emerging, that are already getting big, or devices that don't exist yet. For us, our job is to make sure that we work very closely with our partners, our customers, the chipset partners, the operating system partners, as well as the standard bodies, to have a solution ready not just for your next generation of existing device, but to be prepared for those devices that you are inventing that may not exist yet. So I want to thank you again for listening to this presentation. Thank you.